than what we've been talking about in terms of graphs and lines and everything, but it does connect a lot. The equation that we're going to learn today for an arithmetic sequence is a lot like our slope-intercept form, the y equals mx plus b. It's very, very similar. We're using different letters, different kind of situation, but hopefully you'll see some similarities. So everybody say arithmetic. Arithmetic. How else could I pronounce this word? Arithmetic. Don't ask me which one's right. I don't know. If you watch some videos, they say arithmetic. Some say arithmetic. I say arithmetic. If you want to say arithmetic, I'm not going to kick you out. Okay? It'll be fine. But I'm going to refer to it as an arithmetic sequence. Okay? And an arithmetic sequence is a list of numbers with a common difference from one term to the next. How exciting. All of the questions from our warm-up were arithmetic sequences because we could find the common difference from term to term to term. So an example of an arithmetic sequence, like in our warm-up, 1, 2, 3, 4, 5, ... means it goes on forever. And in this arithmetic sequence, what would the common difference there be? It would be 1. Because from 1 to 2, we're doing plus 1, plus 1, plus 1, plus 1. Okay, a non-example of an arithmetic sequence would be like 1, 4, 9, 16, 25, and so on. Do those 5 terms have a common difference between them? No. I see from 1 to 4 is plus 3. From 4 to 9 is plus 5. From 9 to 16 is plus 7. From 16 to 25 is plus 9. So in this first example, our common difference was 1, but for this list over here, there is no common difference. I'll pause there so you can catch up. Am I going too fast? Yes? Okay. Sounds good. Okay, so that's just a basic understanding kind of what an arithmetic sequence is, right? Now the common difference doesn't have to be positive, right? It could be minus like we saw in the warm-up. We could be subtracting a certain number. As long as it's the same number, it's going to be an arithmetic sequence, okay? So the formula that we are going to use here is a little bit confusing. Stick with me. A sub n, which is like an exponent down on the bottom. Yes, subscript, good. A sub n is equal to D. I'm try and make this as neat as I can. D times the quantity of n minus 1 plus a sub 1. We'll break down what all those letters mean in a second. That's going to be our formula. A sub n is equal to D times quantity n minus 1 plus a sub 1. It's not too scary, right? It's not too bad? No, it's not that scary. We got an A, we got an N, we got a D, and we got a 1. Like, and 1. Okay? So, let's break this down. A sub n. A sub n is our we could just call it our, we could say nth term in the sequence. Nth term. NTH. Nth. Like first, no, sorry. Like fourth? Number. Yeah. But n is the number. Nth term in the sequence. So if I said n is equal to 4, you'd be finding the fourth term in the sequence. If I said n was 10, you'd find the 10th term in the sequence. So it's the nth term. Whatever number is n for the problem, it'll make more sense once we see it. D is the, obviously, difference, the common difference, which we just were able to find in our warm-up fairly easily. And just like someone pointed out, this is basically just our slope, right? It might as well be called M. But it's not. It's D for difference. N is some positive integer like I said, if you were asked to find the 10th term in the sequence, then n would be the positive integer 10. And a sub 1 represents our first term in the sequence. Right? If a sub 1 is our first term, then a sub n is our nth term. And we could also think of this kind of like our y-intercept. When we first brought up graphing linear functions, we said that my b value is where I begin my plotting. Well, in a sequence, you begin with the first term, right? So that kind of connects in that way. Also, let's go ahead and add here for n, that's kind of like our input. And a sub n is like our output. So again, it looks a lot different, but when it comes to our slope-intercept form, it's basically the same thing. Y, my output, equals m, my common difference, times x, which is my input, plus my b, which is my first term in the sequence. It's essentially the same thing, and we'll see that more once we actually plug stuff in and figure things out. Let's start out with a nice easy example so that this can kind of hopefully make some sense. Give me a thumbs up if you're confused so far. No one? Good. We could just go with a hard example then. So for our first example, let's say we got the sequence 1, 2, 3, 4, ...
That is so hard.
Okay. And let's say we're asked to write the equation for the sequence. Write the equation for the sequence. Of these four different components that we have here, the nth term in the sequence, the common difference, a positive integer, and the first term in the sequence, all we're given is 1, 2, 3, 4, ... What can we figure out of those four things? What's one thing we can figure out right away? Liana?
1 is the first term in the sequence.
Exactly. The first term in the sequence, boom, is 1. So we know that a sub 1 is equal to 1. It's my first term in the sequence. You look for whatever number is first. That's the first number in the sequence, right? What else can we figure out amongst those four things? What did we find in the warm-up? Alex?
We can find the common difference.
We can find the common difference. What is the common difference from 1 to 2 to 3 to 4? Plus 1. So D is equal to 1. Now, when we were writing an equation in slope-intercept form, we needed to know two things. We needed to know the slope, and we needed to know the intercept. Well, here, common difference is my slope, and the first term in the sequence is my y-intercept. So if I know my b and I know my m, well, now I can write the equation. So we're going to take our kind of formula, a sub n is equal to d times n minus 1 plus a sub 1. And we're going to plug in what we know, which is a sub 1 and d. So this turns into a sub n is equal to 1, that's my d, times the quantity of n minus 1 plus my a sub 1, which is 1. I'm going to pause there and let you mentally digest that for a second. Give me a thumbs up if you see how we plug those two numbers in and set that up. Anybody see what we did? Okay. What questions can I answer about how we got to this spot right here? Because I know there's definitely going to be some question. Don't be afraid to ask. I just want to help. Everybody see how we got the first term of the sequence, yeah?
Yes.
We just looked for the first number. Everybody see how we found the D?
Yeah.
Yeah? So we just took the D, plugged it in. We took the A sub 1, plugged it in. That's all we got. It's not too bad, right? Now we're going to simplify this. Now we're going to simplify. What can I do with this 1 on the outside?
could distribute it
You
to
could
the
dis-
n and -1.
You could distribute it to the n and the -1. Does that change anything about n minus 1, though? If I multiply by 1, what's 1 times n? N. What's 1 times -1?
-1.
-1. Plus my a sub 1, which was 1. Okay, I distributed that 1. Is there anything else I can do to simplify?
You could add -1 to 1.
Yeah, let's combine these like terms. What is -1 plus 1?
0.
0. So they go away. So I have the equation a sub n is equal to n. Again, starting out simple. This is kind of like our parent function. F of x is equal to x. A sub n is equal to n. It's like the starting point, right? Because take a look. What's the second term in my sequence?
2.
2. What's the third term?
3.
What's the fourth term?
4.
What did we say the 10th term was going to be?
10.
What did we say the 20th term was going to be?
20.
20. So if I was now asked to find the 10th term in the sequence, for something like this, it would be very simple. If I was asked to find the 10th term in the sequence, that's like me asking to find a sub 10. So if a sub n is equal to n, and I plug in 10 for n, well, what is a of sub 10 going to be equal to? It's going to be equal to 10. That's what we mean when we say that a sub n is the nth term in the sequence. You're just going to plug in whatever it tells you to find. If it tells you to find the 10th term, a sub n turns into a sub 10. All you do is plug that 10 in for the n, which in this case, it's nice and easy. We just get 10. If I wanted to find the 100th term, a sub 100 would equal 100. Like I said, starting out with a nice easy example just to kind of understand how this system is working. How does that feel so far? Does it feel okay? Feel good? Feel not so good? Feel very bad? Okay. Is everybody just tired? Yeah? This is not a good lesson to do when you're tired, so I apologize, but we will be fine. Okay? Oop. Let's try another example. Let's say I've got the sequence 2, 4, 6, 8. Oh, sorry. Dot, dot, dot. If we want to write the equation, we got to find the d, and we got to find the first term in the sequence. Who can tell me what's the first term in this sequence? Tia? 2. And Colby, what's my difference, my common difference here in this sequence? We're adding 2. So my d is equal to 2. My a sub 1 is equal to 2. So I'm going to set up my equation. A sub n is equal to d times n minus 1 plus a sub 1. It's a mouthful, I know. And that turns into a sub n is equal to 2 times n minus 1 plus 2. How could I simplify this equation a little bit, make it nice and neat? Alex, what can I do?
You can distribute the 2 to n and negative 1.
Okay. What's 2 times n?
2n.
And what's 2 times negative 1?
Negative 2.
Plus my a sub 1, which is 2. Am I going too fast? Okay. Combine like terms, what's negative 2 plus 2? 0. So we get the equation a sub n is equal to what?
2n.
2n. Thank you. Which means n, okay, if n's representing some number in the sequence, if I want to find the 10th term in the sequence, what's 2 times 10?
20.
20. Because this sequence is going by 2's. So the 10th term would be 20, the 20th term would be 40, the 100th term would be 200. Right? Let's say I was going to find the 16th term in the sequence. Well, it would be a sub 16 is equal to 2 times 16. Right, we just plug that number in for n, essentially. And what's 2 times 16? 32. So if I would follow this pattern, 2, 4, 6, 8, 10, 12, 14, 16, blah, 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 the 16th term in my sequence would be 32. It's a lot quicker for us to do that than it would be to write out every single term all the way up till we get to the 16th term. Hopefully you're seeing some of the similarities between our slope-intercept form and this. If not, you'll see the similarities eventually. Last example. Let's go for a hard one. Let's say we've got the sequence -4, -1, 2, 5, ... I need to find my common difference, and I need to find my first term in the sequence. Well, a sub 1 is the easy part. What's the first term in the sequence? -4. It's right there in the front. It's the first term in the sequence. Don't overthink it. -4. The difference from one term to the next here would be what?
Plus 3.
+3. Everybody with me so far?
Yeah.
So the d is 3. The a sub 1 is -4. If I take my formula, a sub n is equal to all that nonsense. I'm going to plug in 3 for d. I'm going to plug in -4 for a sub 1. See if you can take a couple steps and simplify that equation as much as possible. See what you can come up with. It should end up in the form y is equal to mx plus b. But instead of x, it's an n. And instead of y, it's an a sub n. A sub n is equal to... Good. to distribute the 3 to the 1 to 3 to the negative 1. Good. It's not too bad, right? What'd you get? Make sure. Yep. And then what's negative 3 minus 4? Negative 7. So 3n minus 7. Yep. 3n minus 3. So when we distribute this 3 to the 1, oh yes, sorry. Yes, sorry. I thought you were on the last step. Good, you guys are doing great. Just to move it right along, we distribute the 3 to the n and to the negative 1. A sub n is equal to 3n minus 3 minus 4. What's negative 3 minus 4? Negative 7. So a sub n is equal to 3n minus 7. Right? It's just like y equals mx plus b. Just with different letters. So this sequence, this arithmetic sequence, can be represented by this equation. If I then wanted to find the... Judah, give me a number between 10 and 20. Was it? 13. Okay. If we want to find the 13th term in the sequence, we'll do a sub 13. And just plug 13 in as our input. Right? Here 13 would be the x. We plug 13 in for x. We evaluate for y. It's exactly like we've been doing. So what's 3 times 13?
36. 39.
39.
Then minus 7 is 32.
So the 13th term in this sequence should be 32. Negative 4, negative 1, 2, 5, 8, 11, 14, 17, 20, 23, 26. How many is that?
11.
12, 13. Is that right?
Yes.
Yeah. There's the 13th term. Yeah.
We have to like subtract 1 from 13. Like 10 minus 1.
If we use the unsimplified formula, sure, yeah, but so if I were to keep it like this, then yeah, I could do a sub 13 is equal to 3 times 13 minus 1 minus 4. I still get 36 minus 4, which is 32. So if you want to use the unfinished one, you can. But we break it down just to make our lives a little bit easier. We're used to plugging stuff in for x and solving for y, right? That's like second nature by now. So if we can break everything down to get to this point, it makes our lives just that much easier. Yeah, great question. Give me a thumbs up if you're feeling a little bit better now. We did a couple examples. Okay, cool. Let's go ahead and get started. I don't want to take up too much time. We got a good amount of time to get work.